All right, let's get into the meat of this, graphing sine and cosine. So here's a couple of activities that I would really encourage you to do. Now, both of these links are in the Canvas course under the resources buttons. So I'm not going to take the time and go over them with you. I just want to show them to you really quick so you can see what they look like. So this is what they look like. This one is the graphing sine and cosine amplitude and period. And you notice this one is the cosine, and you can see what happens when you change A or B, and you'll see what that means in just a second. And then the other one is just graphing trig functions. You can choose either sine, cosine, or tangent. And look what happens if you change the periodicity and if you change the amplitude. So those are just some very helpful links that I really encourage you to at least open one time and look at. So in Canvas, underneath the resource buttons, there they are right there. So you can access them and go there. So grab your notes and let's begin looking at what this means for us. We're first going to look at the sine function. So if you have a graphing calculator, you might also want to graph it so you can refer to it while we're looking at it also. So let's fill out the table first. And as we do this, we're going to look at the graph of sine when x is 0, y is 0. When x is pi over 2, y is 1. When x is pi, y is 0. When x is 3 pi over 2, y is negative 1. When x is 2 pi, it's 0. I want you to add to the notes 5 pi over 2, so that would be like a 2.5. So 5 pi over 2. And then also in the negative direction, add that negative pi over 2 so that we can see that it's a negative 1. So you're just going to add to that table right there so we can just see the graph a little bit better. Then graph those points over here. So along the x positive, we're just going to make this go from 0 to 2 pi. And in your notes, that's already there. So go ahead and fill in those values and draw that graph. You might need to pause the video and do that. And then look at this information. The y-intercept is at 0, 0. How many cycles are there from 0 to 2 pi? That should say 2 pi in your notes. There are 1. What is the amplitude? And these are opposite in your notes. So the amplitude is 1 and the period is 2 pi. So complete those for sine. Let's look at how we were going to determine the number of cycles from 0 to 2 pi. That should say 2 pi in your notes. And then find the period for each graph. Well, if you have the graph to look at, you can just look at the graph and figure out what that is. So you always look from 0 to 2 pi. And for this graph, 0 to 2 pi goes all the way over to here. So how many cycles are there? Well, there's 1, 2, 3, 4. So there are 4 cycles. And then what is the period? So how long does it take to go through one complete cycle? And if you notice on this first one, it took from 0 to pi halves. So the period is pi halves. The next example, looking at this graph here, ignore the watermark there. So this one asks cycles from 0 to 2 pi. Well, this graph only goes up and then to the 0 to 2 pi, and it's only half of a complete cycle. So number of cycles from 0 to 2 pi would be 1/2. And what is a complete period for this one? It goes from 0 to 4 pi. So a period is 4 pi long. Let's talk about vertical and horizontal compression. Well, as you look at the equation of a trig function, you notice there's two places where you could have a coefficient. You could have a coefficient in front of the trig function, and we call that coefficient A, so we can kind of keep them separate. Or we could have a coefficient in front of B, or in front of X, and we call that coefficient B. So if you noticed on those GeoGebra activities, it talked about A and B, or it also showed a vertical or a horizontal amplitude or differences there. So that's where those come from. So A, and you might want to make a note of this, A represents changes in the vertical or in the amplitude. And B, so the coefficient in front of X, makes changes horizontally or with the cycle. So A is going to change the amplitude and B is going to change the cycle. Now here's another link, and this is also in the resources link on Canvas page. That is pretty cool. It shows a calculator with a sine function graphed and sliders for A and B. So just another way that you can look at what happens when you change A and B. So in the standard equation or in the parent function, A would be 1 and B would be 1. So if you change them at all, that's going to make the graph different. How do you find the period of a function? It's really useful information here. So the period of a function is found by taking, I'm going to scoot this over right here so you can see this. The period of a function is by taking 2 pi and then you divide it by b, because if you remember, b changed the periods of the function. So if b is 1, the period's just going to be 2 pi. If b is 2, then the period is going to be 1 pi, and so on. So that b represents the number of cycles. So you take 2 pi, divide it by the number of cycles, and that's how you find the period. So part A, y equals sine of theta. How many are number of cycles between 0 and 2 pi? That should say 2 pi in your notes. And we've done this one already, so we found out that it has 1 cycle and each period is 2 pi. Part B, sine of 2 theta. Number of cycles between 0 and 2 pi would be 2, because B is 2 and B represents the number of cycles. The period, well, if we take 2 pi and divide it by 2, the number of cycles, we just get pi. So the period is pi. Part C, now this time B is 4. So how many number of cycles between 0 and 2 pi? Well, the number this time is 4. And then 2 pi divided by 4 would be pi over 2. So that means on a graph between 0 and 2 pi, there would be 4 complete cycles. So that's really similar to example 1 that we did earlier. And each cycle would be pi over 2 long. Part D, y equals sine of 1/2. Well, in this case, b is 1/2. So the number of cycles would be 1/2. There's half of a cycle between 0 and 2 pi. And the period would be 2 pi divided by 1/2, which is the same as 2 pi multiplied by 2 over 1. So that would make 4 pi as the length of the period. And the last example, y equals sine of 1/4 theta. B is equal to 1/4, so the number of cycles between 0 and 2 pi would be 1/4. So you'd only have 1/4 of a cycle. So this means the periods are really stretched out. And the periods would be 2 pi divided by 1/4, which is the same as 2 pi times 4 over 1. So each period would be 8 pi long. How do you find the amplitude, the number of cycles, and the period? Well, look at this equation for part A. We have 3 sine 2 pi x. So, like you remember, we find the amplitude by looking at the coefficient in front of the trig function. So this time the amplitude is 3 units high. The number of cycles is the number in front of the x. So the number of cycles is 2 pi. In example B, where you have that negative, what does that do to it? Well, if you graph this, and by the way, I encourage you to graph these on a graphing calculator. You'll have to remember to change it to radians so that you can have the right degrees there. But anytime you have that negative out in front, that's going to reflect it, and it reflects it across the y-axis. Across the x-axis because it's out in front of it. But it doesn't change the amplitude. So the amplitude is still just going to be that high. So what we have to do is we have to take the absolute value of A, because we always want the amplitude to be a positive number. So the amplitude is 2. Cycles is the number in front of the x, so the cycles is pi over 2. And the period is 2 pi divided by pi over 2. So if we do that, we have a number being divided by a fraction. So I'm going to invert and multiply by 2 over pi. The pi's cancel out, and you end up with 4. Part C, A, is the number in front of the trig function, 0.5 or 1/2, and sine, or the number of cycles, would be 3, and the period would be 2 pi over 3. What happens when the value of A is negative for A sine of bx? Well, we found that already. It makes a reflection across the x-axis. Okay, hope you can read that. So let's look at what that graph would look like instead of going. So a couple of things are going to happen to that parent function of sine. So if I just really quickly sketch in the sine function, we know it crosses at 0, 0, and it comes up and goes down and looks something like that. And its original period would go from 0 to 2 pi. So this is interesting. Graph this on your graphing calculator. Just do the sine of x, and that's the black one. But then, what if I make it negative? Well, it's going to flip it across the x-axis. So instead of going up, it's going to go down. So it's going to kind of do like a mirror image. So that one would be the negative sine of x. And then the 2 makes the amplitude higher. So it's going to go, instead of peaking out at 1, now the amplitude is going to be up at 2. So the amplitude would be 2. It would be flipped across the y-axis. The period would stay the same because there's not a coefficient in front of x. To write an equation for each sine function, first thing we do is find the amplitude. Now, this one has an amplitude of 1. Goes from -1 to 1, so the amplitude is 1. There are 6 cycles, or 6 periods, from 0 to 2 pi. So B is 6, so our equation is y equals sine of 6x.